Hello everyone, and thanks for watching Edupedia World videos. In this video, we begin our study of the topic of functions. Now, functions are, the word used generally is mapping. Functions are a mapping from one set to another. So just to take a simple example, y is equal to 3x. Right, and let's say if it is defined on the set R, where R is all real numbers, right? Then you know what the graph of y looks like. It would be something like this, where when x is 1, y is 3, when x is 2, y is 6, and so on. Right, so it is mapping from one set to another. Right, if you took a somewhat different case, let's say you took x to the power 4, then the curve would be something like this. Right, where if this is 2, then this would be 2 to the power 4, which is 16. So this would be the curve of x to the power 4. Now, the most important property of a function, and it is true for every function, is that for a single value of x, you only have a single value of y. One value of x goes to one value of y. So if x is 2, you know what y is. Y is 2 to the power 4, that is 16. Now if x is minus 2, even then y is 16. So it doesn't mean that one value of y, 16, corresponds to only one value of x. The inverse is not necessarily true. Right, it might be true, it might not be true. So one value of y can correspond to many values of x, but one value of x can only correspond to one value of y. Otherwise, you would not know what the value of y is, right? What the value at x is equal to 2 is. That's why you can often see functions like this. The end part is obviously not true. You can often see functions like this, where at the same value of y, you can have many different values of x. But you'll never see a function like this, right? Because at x is equal to 4, you won't know what the value of function is. Is it 4 or is it 2? Right, so you'll never see a function like this. At one value of x, there is always only one value of y, though at a particular value of y, there can be many different values of x. Right, if you just take y is equal to sine x, and you take, let's say, y is equal to half. Y is equal to half means x can have many values, right? 30 degrees, 150 degrees, 390 degrees, and so on. So x has many values. But if I give you, say, x is equal to pi by 6, then y only has one value, sine of pi by 6, which is half. If at a particular value of x, we did not know what the value of y is, or there is more than one value of y, then it is not a function, plain and simple. So this is a property of every function. Now the inverse is a property of some function. We will study that in a moment, that one value of y corresponds to only one value of x, but one value of x corresponding to one value of y is true for every function. If this is not true, it is not a proper function. Right. So let's look at one function and see how properties relate. Let's say fx is x squared. Now fx is generally written as f going from a to b such that fx is x squared. This tells you the domain and the range. This is something you've already done before in 11th class. So a is the domain, that is the set of numbers for which the value of x is defined. X can take a value belonging to the set A, and b is the range. That means y, which is f of x or x squared, can take the value in the set B. Right. Now a can be many different things. They both can be all real numbers. A can be real numbers, b can be just positive numbers. That would also be fine. Let's take some finite sets to begin with. Let's say a is the set of numbers minus 3, minus 2, minus 1, 0, 1, 2, and 3. And let's take b to be the set of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So let's represent these two sets in a diagram, and this is how we generally represent diagrams in a set. So the set of A would be -3, -2, -1, 0, 1, 2, 3, and B would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So at -3, what is the value of y? If x is -3, y is x squared, that is 9. So -3 goes to 9. So we draw an arrow of this. -3 goes to right. What does -2 go to? It goes to 4. Now see, only one arrow will go from left to the right. -2 cannot go to both 4 and 2. Right? That would not be a proper function. -1 goes to 1. 0 goes to 0. What does 1 go to? It goes to 1. 2 goes to 4. And 3 goes to 9. Now see, here we see the asymmetry between x and y. The value y is equal to 1 can have two values of x, -1 and 1. So an arrow can have, two arrows can have the same end point, but two arrows cannot have the same starting point. One cannot go to both 1 and 4, then it would not be a proper function. Right? When you say f of x is equal to this, you put in a value of x, you get a particular value of y. Right? So two values of x can have the same value of y, which is 4, but one value of x can never have two different values of y. Right? So this is basically me just trying to show you how you would represent a function, and the sets could be finite or infinite. In this case, these are finite sets, and this is the sort of map which you could represent to show those functions. So let's look at a few general cases, and now we'll try to divide functions into some categories. So let's just try to look at a few diagrams first. So I'm going to try to show you different types of functions. Let's say this is f1, this is f2, this is f3, this is f4. All functions are defined from a set A to a set B, where A and B can be different in different cases, in the case of f1 and f3 for example, or they can be the same. And let's say you have numbers like, let's say on the left you have numbers, right you have letters. Just for the sake of consistency, they can be anything obviously. So let's take 1, 2, 3, 4 here in every case. A, B, C, D, E, F. Right, so these will end up being different types of functions based on how the mapping goes. So let's say A goes to 1, 1 goes to A, let's say 2 also goes to A, 3 goes to C, and 4 goes to D. Let's say 1 goes to B, this is completely arbitrary, 2 goes to A, 3 goes to D, 4 goes to E. Let's say 1 goes to A, 2 goes to B, 3 goes to B, and 4 goes to C. And 1 goes to C, 2 goes to A, 3 goes to B, 4 goes to D. Right, so these are 4 different types of functions, and let's look at a few definitions. The first is a function f is said to be one-to-one, or another word for this is injective if the distinct elements, if the images of distinct elements, by the way, image is y, so the image of 1 will be A under the function f1. Images of distinct elements are distinct. Which means for all x1 and x2 belonging to A, f of x1 equals f of x2 means x1 equals x2. Now this is the inverse of what we were talking about. Right, we said that every x has to correspond to one value of y, but every y does not have to correspond to one value of x. For example, the value of y, which is a here, corresponds to two values of x, 1 and 2. So this is not one-to-one or injective. The name also suggests it's one-to-one. So one-to-one means inverse is also true. That means if you have one value of y, then that corresponds to one value of x only. Right, so two values of x cannot ever have the same value of y in a one-to-one or injective function. Remember, if the inverse wasn't true, it wouldn't even be a function to begin with. So the way I said it was, two arrows can never have the same beginning. Right, two lines or arrows can never have the same beginning. They can have the same end point. If no two arrows have the same end point, right, then the function is one-to-one or injective. I just remember it by the phrase one-to-one, which means one value of y corresponds to one value of x. That need not be true for all functions. It is true for one-to-one or injective functions. The inverse is true for all functions. One value of x gives you one and only one value of y. Right, so this is one definition. Another is a function f is said to be onto, O-N-T-O, or surjective is the other word used, if every element of y is every element of B in this case rather is the image of some element in A. So this has to do with the sets A and B as well. So for example, a few minutes ago we looked at A is equal to minus 3, minus 2, 1, 2 and 3, and we took B to be the set 0, 1, 2, 3, 7, 8, 9. Now if we look at the number 4 in the set B, that is the image of an element in A. It is the image of two elements in A, minus 2 and 2. But if you look at the element 6 is not the image of any element in A. So this is not an onto or surjective function. Now if the exact same function fx is x square was defined from A to B, but B was the set 0, 4 and 9, then the very same function would become an onto or surjective function, because now every element of B is the image of some element of A. Right, so one-to-one is actually a property of the function, but onto or surjective is not just a property of the function, but also the property of sets on which it is defined. Right, so every element of B should have an element of should be the image of an element of A. Finally, the third definition is a function is called bijective if it is both injective and surjective. Right, so I'll just use the letters I, B, A dash to represent them, and let's look at these four. Right, one is a general function. It is not one-to-one because the value 1 and the value 2 in the set A both give the image A. One-to-one means images of distinct elements are different. Images of 1 and 2 should be different, which is not true. So 1 is neither injective and nor is it surjective. Surjective means every element of B is the image of some element of A. But if you look at the element small b or E or F, they are not the image of any elements in A. right? So it is neither injective nor surjective. Let's look at this one. It is injective but not surjective. It is injective because distinct elements of A correspond to different elements in B. See, no two arrows have the same endpoint in B, right? So this is injective. 1 goes to a different element, 2 goes to a different element, 3 goes to a different element, 4 goes to a different element, right? So it is injective, it is one-to-one, but it is not surjective because there are the elements C and F which are not the images of any element in A, right? So it is not surjective, but it is injective. This is surjective but not injective. Not injective because it is not one-to-one. 2 and 3 both have the same image B, so it is not one-to-one, right? But it is surjective because A, B and C, all three of them are the images of at least one element in A. There are no elements in the range left over, right? There are no elements in B which are left over. So it is surjective but not injective, and it is both surjective and injective, therefore it is bijective. Obviously it is one-to-one. 1 goes to C, 2 goes to A, 3 goes to B, 4 goes to D. No two arrows have the same endpoint. But it is also surjective because A is the image of some element, B is the image of some element, C is the image of some element, and D is the image of some element, right? So I'll just repeat the definitions once more. A function is said to be one-to-one or injective if the images of distinct elements are distinct. That means no two arrows have the same end. Remember, the opposite of this has to be true for each and every function, right? Every x has to give only one value of y. That is true for every function. Every y has to correspond to only one value of x. That is a subset of those functions which are the one-to-one or injective functions. Now, if every element of the range, every element of the set B is the image of some element of set A, there are no elements left over. See, these are the leftover elements. In these two cases, there are no elements left over. If there are no elements left over, it is surjective. And finally, if it is both injective and surjective, or if it is both one-to-one and onto, then it is referred to as bijective. Right. Now, there are certain characteristics of these properties. One is f going from A to B is onto if and only if the range of f is B. Right, so let's look at the example. Had f went from A to B, where A was -3, -2, -1, 0, 1, 2, 3 to B. And let's say B was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is defined from this to this. So this is the domain. Based on this domain, what is the range? This domain means the range is the set 0, 1, 4 and 9. This is the range of this function. But this is the set B. These two are different, therefore it is not onto. If the set B was simply 0, 1, 4 and 9, then obviously it would be onto, and this would be the same as the range. So if it is defined from A to B, A is called the domain, and B, I made a mistake, I think in the beginning I said B is the range. No, the range is the values f might take. The range has to be a subset of B, but B might have some extra terms as well. For example, if you take f going from the real numbers to real numbers such that y is equal to x square, then the domain is real numbers, but the range is not necessarily real numbers. The range is real positive numbers, right? So this is not an onto function. So B is not necessarily the range. If B is the range, that means if this was R plus the positive real numbers, then it would be an onto function, right? Also, another property is if x is defined from x to x, which is from a set onto that same set, and the other property is also important, x is a finite set. then these two statements imply that if f is onto, it means it's 1 to 1, and if f is 1 to 1, that means it's onto. And that's quite easy to see. Let's say X is an element which is a set which has 62 elements. Just a random number. Then it goes from the set X to the set X which has 62 elements. But now no two elements 1 and 2 can have the same image, right? Because it is, let's look at this one first. No two elements can have the same image if it is 1 to 1. But that means there are 60 elements, two elements can have the same image, so there will be 62 images, and there are 62 elements in this, so obviously they will cover the whole range. So it is onto as well. If it is onto, that means you have 62 elements going to 6 elements, and you cannot have one element going to 2 elements. That means obviously you can have one element going to one element each, and no two elements will have the same entries. Otherwise, this number would be less than 62. This is only true for finite sets, of course. This is not true for infinite sets, such as the set of real numbers or the set of natural numbers. In the next video, we'll look at how to combine or create the composition of two functions. Thank you. Solution of food from the shiz of Marcus Gale, Nia, Marcus Rahagulu, or Ilut Sienene.